Okay, so today we are starting 3.4, which is real zeros of polynomials. And today we are going to find all of the rational and real zeros of polynomials. You did do this in Algebra 2. So hopefully as we go through some of it, it'll come back to you. But some of it is a little bit tougher. Okay, so anything that was in that first blue box is what I want you to fill in, the rational zeros theorem. Okay, so your rational zeros theorem, let's talk about what all this information means. So it starts off with if the polynomial p of x equals, and then we have this whole long variable filled expression here. So let's talk about it. It really just means that your polynomial is going to be in standard form of what you're used to seeing. But if you have x to the n would be what? What would n be? The degree, right? So n is just the degree of the polynomial. So if the degree was 5, see how this says n minus 1? That's just saying the next term would be what?
1 degree less.
It would be 1 degree less, which would be 4, and then it would keep going until you got till x to the first, and then you would have the constant term, which would be a sub 0. So all of the a's represent what? What are those called? Coefficients, right? They're just the coefficients. So a sub n means it's the coefficient of x to the nth power. A sub n minus 1 is the coefficient of x to the n minus 1 power. Okay, so this is just your polynomial in standard form. And then it says it has integer coefficients. For every rational zero of p, it is of the form p over q. Or what's another way I could say that besides p over q? What does that mean? P divided by q. Okay, so we are going to be dividing. This is where p is a factor of the constant coefficient a sub 0. Where is a sub 0 in my equation? So at the very end, right? Okay, that's just your constant term. And then this one, it says it's the factor of the leading coefficient a sub n, which is where? In the front. So for the next question that I asked you to think about, it says, how would you tell a friend how to use the rational zeros theorem? So you're thinking about how do you put that in your own words. So what I said is just what we were talking about. The p is going to be factors of your constant term, which is just the last number. And your q is going to be factors of the first term, which is your leading coefficient. Okay, so p over q. Does that sound familiar yet? Okay, maybe when we go through the first example, you guys will remember the p over q. Okay, so p over q is the form of the rational zero. So p is going to be factors of the last number, q is going to be factors of the first when it's put in standard form, and then we are going to be dividing those. Yes, yep, for leading coefficient. Yep, so the leading coefficient, and then that will be the constant. All right, let's go ahead to example 1. So read over the example 1 directions. And then, Emily, tell me one thing that example 1 tells us to do. Okay, so we have to find the rational zeros. Okay, and then Jackie, what other thing is it asking us to do? That, so that is what we're going to do, but what about in the directions?
Write the polynomial in factored form.
Yes, okay, so basically your two different answers here. First, you're going to find the rational zeros, and then the second thing you're going to do is write the polynomial in factored form. Okay, and the first one we are going to do without a calculator. You will have to know how to do it with and without a calculator. All right, so step 1, it says list the possible rational zeros. Okay, so that's for step 1. So we are going to do P over Q. And just like we talked about before, P is going to be the factors of your constant term. So Jordan, what is our constant term for part A?
I don't know.
That, okay, so yeah, because your constant term is always what? Just your last number, okay? So it'll be the factors of 35. Okay, and then, Paul, the factors of Q are going to be what? So factors of Q are always factors of the what? Did you write this down from up here? Right? They're always factors of the... Okay, leading coefficient. Yep, so what's my leading coefficient? Yep, your leading coefficient is 1. Okay, so that will be factors of 1. Okay, so then we're going to go ahead and write those out. When I write them, I will write them in numerical order. So what is the first factor that goes into 35? Okay, 1. Now, and it's 1 times what is 35? 35. So you could do 1 times 35 to get 35, but you could also do negative 1 times negative 35, right? And that would still give you positive 35. So when you write out the possible zeros, you always have to include plus or minus. So it's plus or minus 1. What's the next one? What's the next one that goes into 35? 5. And then what's the next one? 7. And the last one? 35. And then the factors of 1 are just going to be plus or minus 1. So remember, P over Q means P divided by Q. So what I have to do is divide every number on the top by every number on the bottom. And for this one, we just have 1. Anything divided by 1 is just going to be what? Itself. So this would be plus or minus 1, plus or minus 5, plus or minus 7, and plus or minus 35. Yes. Okay, so yes, you do have to write plus or minus for every single one. So these are the possible rational zeros. What terms does rational exclude? I keep saying possible rational zeros, but what is different from a rational zero? What are the other types? Irrational zeros, right? Irrational zeros are going to have like square roots in them. Rational zeros is really anything that can be written as a fraction with integers on the top and the bottom. So these are all of your possible rational zeros. Okay, so that's your first step. Now step 2, it says check which ones are actually zeros. So these are what's possible. Now we're going to find the actual zeros using what? Synthetic division, which is what we did yesterday. Okay, so we have to use synthetic division. Okay, we are going to use synthetic division until you have a quadratic equation. Then you are going to solve the quadratic equation, and if the quadratic equation that you have is not factorable, then you are going to use, this should say formula, the quadratic formula. Okay, so some of these you are not going to have to use the quadratic formula for, others you will. Okay, the first ones that we're going to do are going to be more basic. Alright, so if you want to check which ones are actually zeros, let's talk about all the possibilities. How many possibilities do I have here? I have 8, right? 1, negative 1, 5, negative 5, 7, negative 7, 35, negative 35. You can just guess and check every single one until you find one. How do I know, using synthetic division, when I have found a zero? When the remainder is 0. So if the remainder is 0, we know that that's a factor, so we know that it's going to be a 0. So what I like to do, I like to be very systematic. I check 1, then I check negative 1, then I check 5, then I check negative 5 until I find 1. Okay, so let's go ahead and check 1 first. Now I said that's how I do it. You don't have to. If you were feeling good about 7 being a 0 and you wanted to check that first, then you absolutely could. So I'm going to set up my synthetic division. So I have my coefficients across the top. You guys remember that from yesterday? Okay, and I'm going to bring down the 1. So the 0 I want to check is 1. So I'm going to do 1 times 1, which is 1, add straight down, multiply across, add straight down, multiply across, add straight down. Is this going to be a 0? Nope. Okay, so if the remainder is not 0, if r does not equal 0, then the value is not a 0 of p of x. Okay, if the remainder is not 0, then the value is not a 0 of p of x. Okay, so I'm going to try again. Okay, so now I'm going to try negative 1. Remember, I could try any one of those. I just like to go in order. So 1 times negative 1 is negative 1. That's negative 12. Multiply across, I get 12. Add straight down, I get 35. Multiply across, I get negative 35. Okay, yay! My remainder is 0. So what that means is negative 1 is a 0. Negative 1 is going to be one of my zeros. Okay, once you've found one of your zeros, if you have a quadratic equation, then we can solve the quadratic equation. So you're only going to do synthetic division until you get a quadratic. Is this a quadratic? Yeah, how do we know? So if this is my remainder, what's this? The number. This is going to be the coefficient of x. This is going to be the coefficient of x squared. Do you guys remember that from yesterday? Okay, so then we're going to set up my quadratic. Set it equal to 0. And we are going to solve the quadratic. Okay, and I'll give you a minute to do that. So if it's factorable like you want me to factor, okay, so Sydney, what did you find, George, that multiplied to 35 but added to negative 12?
7.
Okay, good. In this case, they both would have to be negative, so minus 7 and minus 5. How did you guys do with that? Good. Okay, so then you can set each one of those equal to 0 and solve. So if x minus 7 equals 0, x would be 7. If x minus 5 equals 0, x would be 5. Okay, so from this, we found that 5 and 7 are zeros. Okay, so now what we're going to do is we are going to list all of our zeros. And I'm just going to list them in numerical order. So negative 1, 5, and 7. And then we're going to write those in factored form. Okay, so remember with factored form, you're going to start with p of x. That's the polynomial. And then all of your factors are going to be of the form x minus c. So if you do x minus negative 1, what's that going to end up looking like? Okay, good. And then Michael, you want to finish this one for me? Good, x minus 5 and then x minus 7, right? Okay, what questions do you guys have for me on that? That's okay? Alright, let's try the next one then. you to start with step 1. So what are we doing for step 1? Good, P over Q. Okay, so Griffin, what's going to go on top? The factors of what?
-6.
Okay, good. And what did you write down for those factors?
+(-1), +(-2), +(-3), +(-6).
Good. Okay, Sophie, what about for the bottom?
You have 3 to the lead coefficient,
Yep.
and then I had ±1 and ±3.
Perfect. Okay, so 3 because it was the leading coefficient, -6 because that was your constant term, and then we have to divide. So the first thing I would do is divide everything by 1. When I do that, I'm going to get my same values. 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. But now I also have to divide them all by 3. So if I do 1 divided by 3, I'm going to leave that as plus or minus 1/3, 1 over 3. Okay, then I'm going to do the same thing with 2. So that will be plus or minus 2 over 3. The next one would be 3 over 3. But what is 3 over 3? 1. Don't I already have that in my list? Okay, so I don't have to write it again. And then the last one will be 6 over 3, which is what? 2. And then that's already in my list, so I don't have to write it again. Okay, so here is my list of possible zeros. Okay, so remember earlier I told you you have to know how to do this with and without a calculator. In some cases I am going to let you use a calculator, and that's so you can narrow down your guess in your checklist. Okay, and we're actually, let's go back to the front, and underneath step 2, we'll make a little note. That way if you're going back to watch your steps, you'll see what it is. So if you can use your graphing calculator, you can graph the polynomial. So you can use your graphing calculator. To find, what would you be looking for? How would that help you if you graphed it on your graphing calculator? You'd see your x-intercepts, right? And what are x-intercepts? They're your zeros. So then instead of having to guess and check, you'd be able to pick out some of the zeros, and then you would know that you would try one of those first. Okay, so you can use your graphing calculator to find the x-intercepts, but you must verify using synthetic division and solve a quadratic equation. Okay, so you're still going to do synthetic division to verify, and then you would solve a quadratic equation. Okay? So we're going to do that with part B. So go ahead and graph that for part B. So you have 3x cubed or if you guys want to guess and check, you could do that. Okay, so once you graph, remember this is helping us because now I don't have to pick and choose from that list. Now, according to the graph, what would be a good option of a 0 to check? Okay, 3 looks good. -1, right? Okay, so 3 or -1. Either of those would be good choices because those are our x-intercepts. Which one do you guys want to do together? Which one do you guys want to do? -1? Okay, so I have 3, -4. Do I have any placeholders for this equation? Any missing terms? Okay, no. Alright, so we're going to try -1. We chose -1 because it looked like it was a 0 on the graph. You could also use your table. And how can you look at your table and know it's a 0? The y is a 0, right? Okay, so then we're going to multiply across, which would be -3. So it would be -7, +7, -6, +6. Okay, great. So our remainder is 0. So what we have done is we have verified that -1 is a 0. Can I make a quadratic equation from this? Yep. What do you guys think? Is this one going to be factorable? Let's try it. So if it's 3x squared, it has to be 3x and x. You got it? Oh. Okay, so you have a -6, which means your signs have to be what? Positive and negative. They have to be opposites, right? Okay, so they have to be opposites, and I know this is factorable. How do I know this is factorable? How do I know this has to be factorable? Not necessarily. What are we doing with this? What are part of the directions? I have to write it in factored form. If I have to write it in factored form, is it going to be factorable? Yeah. Okay, so yeah, you can definitely factor this. Alright, so it has to multiply to -6 but add to -7. What should we do? +2 -3. Let's try it. So 3 times -3 is -9. -9 plus 2 is -7. Does that work? Yep. So then I can set each of these equal to 0 and solve. So 3x would equal -2, so x would equal -2/3. Here x would equal 3. Okay, so don't forget that -1 is a 0 from what we did above. And then we also have -2/3 and we have 3. Okay, so our rational zeros are -1, -2/3, and 3. And then we're going to write this in factored form. So I have P of x equals, okay, Nathan Town, what's my factor form for -1? Good. And then this one. Some of us might be thinking x plus 2/3. But just like yesterday, we're going to write a little note because what do you think we're going to have to do with the coefficients? Yep, and they have to be, yeah, they have to be what? you need what type of coefficients?
Integers.
Integer. So you need integer coefficients. Okay, so it wouldn't be x plus 2/3. What would our factored form be? Wouldn't it just be right here? Right? 3x plus 2. We already had it in factored form. Same thing with 3. It would be x minus 3. So, yep, the factored form is 3x plus 2 times x minus 3. Okay, and those would be your two final answers. Okay, so for example 2, this one says find all the real zeros. When it says find all the real zeros, that implies that you could have rational zeros and irrational zeros, but you might not. Okay, they might all be rational or they might be a mix, so it just depends. So we're going to use the same steps as in example 1, but some of them are actually special cases. So we're actually going to do part A 3 different ways. Okay? So we're going to start off doing it just the way we did before. Okay, so this will be method 1. So we would do our P over Q. And see how we can already tell that the leading coefficient is 1 here? So instead of just writing it over 1, let's just go ahead and write what all the rational zeros are going to be. Okay, so it's going to be plus or minus 1, plus or minus 2, plus or minus 4. And those are the possible rational zeros. Okay, and then step 2, you can guess and check. You can pick your own ones to guess and check, or you can graph it and find what? Okay, or you can graph it and you can find the x-intercepts. What do you guys want to do? Okay, go ahead and graph it. I'll let you guys pick the 0 that we find. Okay, so when you graph it, you can see a lot of different zeros on there. If you haven't already set up your coefficients for the synthetic division, will you do that? Okay, so set up your synthetic division. What do we have to remember for this one? Yeah, you have placeholders, right? Nathan Thompson, can you tell me what my coefficients are going to be across the top?
Yeah, 1, 0, -5, 0, 4.
This one was tricky because how many placeholders did I need?
2.
I needed 2 of them, right? So I have x to the 4th, I'm missing x cubed, I have x squared, I'm missing x, and then I have 4 here. Okay, so go ahead and check to make sure you set that up correctly. And then, what 0 do you guys want to try first?
2.
2. We'll do 1 first. Yeah, Farai, were you going to ask me something?
Oh, no.
Okay. So we're okay with this setup? So your zeros are your placeholders? Okay, so now we're going to do synthetic division. Okay, so 1 times 2 is 2, add straight down. 2 times 2 is 4, add straight down. You have -2, add straight down. Yay! Okay, so what that means is 2 is a 0. Now, when we did this in the other examples, when you were done, this was always what kind of equation? quadratic. What is this one? This one is a cubic. Let's think about maybe why that happens. So I started with x to the fourth. When you're dividing by 2, it's really like you're dividing by what factor? X minus 2. So if you're doing x to the fourth and you're dividing that by an x, your next one should be a cubic. So I'd have to do this one more time in order to get a quadratic, but I'd have to use these same coefficients. Okay, so then these would be my new coefficients for my second time. So you would do synthetic division again. I'm just going to shorten this to myself more room. Okay, so my new coefficients are going to be 1, 2, negative 1, negative 2. You do not use the 0. Okay, so all I did is I took these coefficients, I'm using those again. And then you guys said that you wanted to try 1 as a 0, as that was a different one. Okay, and again, you could just pick that from the list, or it is one of your x-intercepts. So 1 times 1 is 1. Add straight down, you get 3. That would be 2, 2, 0. So now from here, I have a quadratic. And from this, 1 is a 0. Okay, so you can do synthetic division more than once. Why would I have to use these as my coefficients? Why couldn't I do this again with a different one? I'd still get a cubic function, right? I'd still be dividing a 4th degree polynomial by a 1st degree polynomial, and it would only go down once. Yes, Sam?
So in step number 2, you would have to get it down to a quadratic to put it into the quadratic formula.
Yes. Okay, so once you have the quadratic, then you can set up your quadratic equation, and you can either factor or you can use the quadratic formula. This one is factorable because you have all rational zeros for this. What's going to multiply to 2 but add to 3? Give me 1 second. Okay, go ahead.
You can't use the same 0 like for the second one.
In some cases you can.
'Cause I tried it and I did the same thing.
And you what?
I did the same thing.
Yeah, but did you get 0? Right, so that means that it doesn't happen twice. So some zeros can occur more than once, we'll actually talk about that in the next one, but for this one it won't.
Yeah.
Oh, only if it has like two.
So-
'Cause I did 1 twice. So then only if it has 1 twice on X.
We'll talk about it in the next one. And I'll hopefully clear up what you're asking. Yeah, Jackie?
Why can't you factor the first one with the
So you mean the cubic?
yes.
Yep.
I did that and I got all of those zeros.
Well, that is our second method. Okay, so method number 2. Okay, method number 2 would start off like method number 1, but instead of doing synthetic division again, this is special, right? This is cubic, so that would be x cubed plus 2x squared minus x minus 2 equals 0. And you could actually factor by grouping. Now that is something that's special. That is not going to happen all the time. In some cases it will. And if you recognize that and can do it, that's absolutely a valid method. That would be perfectly fine. So if you factor by grouping, right? Jackie, what did you pull out of the first 2?
X squared.
Good. And then what do you have left inside?
X plus X.
And then what'd you take out of this one? Yep, so it would be negative 1. And if you take out a negative 1, what would you have in this? Yep. Okay, so because those match, sometimes if you try to factor by grouping, they won't match. And if they don't match, you can't continue. You'd have to do synthetic division again. This one, like I said, is a special case. So I have x squared minus 1 times x plus 2 equals 0. X squared minus 1 is x plus 1 times x minus 1 times x plus 2. So then you would get from this x equals negative 1, 1, and negative 2. And then where would the other 0 come from? The first thing that you did, which would be here, 2. Okay, so method 2, you would do the same thing up until you get here. You could recognize that that is a cubic that can be factored by grouping. Or, did any of you notice what you can do off the bat? You can factor it right off the bat, can't you? Okay, so method 3. Okay, so factor x to the 4th minus 5x squared plus 4 equals 0. Okay, and again, if you recognize that right away, you could absolutely do that. Okay, so x to the 4th, what times what is going to make x to the 4th? X squared. So this would be x squared and x squared. And then what's going to multiply to 4 but add to negative 5? Yep, negative 1 and negative 4. Okay, so then we can go ahead and factor both of these. Both of those are special because they're both what? Yep, they're both perfect squares, so it's the difference of 2 squares. So it would be x plus 1 times x minus 1, x plus 2 times x minus 2. So from there, you would get the same thing. Your zeros, negative 1, 1, negative 2, 2. Okay, so any one of those methods are correct.